In today's lecture, we are going to learn how to find inverse Laplace transform and how to use the Laplace transform with its inverse to solve some initial value problems or some differential equations with specific initial conditions. Let me remind you what we studied in the previous lecture. If I have a function f of t, just 1 minute. So my function f of t with t greater than 0, and I need to find its Laplace transform. Laplace transform is given to be an integral, by the definition, integral from 0 to infinity exponential st times f of t dt. And this new function, the resulted function, it is a function, let me call it f capital of s. So starting from now, Laplace of f small of t, it is a new function with a new variable f capital of s. What about of Laplace transform of the function g small of t? It is g capital of s. What about of Laplace transform of small apple t? It's given to be big apple of s. Okay. Now the inverse. I have a small question. Do you remember the inverse of integration is what? Inverse of the integration?
Differentiation.
Differentiation. Great, Islam. So the concept of inverse of any operator or any function, I think it's easy. So do you remember also, if I have a function f, so the notation for its inverse is what? The notation for the inverse of any function f is what? Do you remember?
F power -1.
F power -1, yes, you are right, great. So also I'm going to use this notation and this concept of the inverse Laplace transform. Here the objectives of our lecture, and here let me introduce the concept of the Laplace transform, how to be used to solve initial value problem. If I have initial value problem here, I'm going to apply Laplace transform for both sides of my differential equation. Then I'm going to find ys capital, take inverse Laplace to get y small of t. By the way, this diagram is the most important thing of Laplace transform. I'm going to study my lecture or to explain my lecture, then I will go back to this slide. Here are the notations. So let me call my function f small. I'm going to take is Laplace transform. I'm going to call it f capital of s. Now I'm going to apply the inverse Laplace for both sides. So now here I have a Laplace of f of t is given to be f capital of s. Okay, I'm going to take the inverse Laplace for both sides. So here Laplace inverse and here Laplace inverse, or bracket like this, no problem. Do you remember if you have an operator with its inverse or you have a function with its inverse? So what can I do now?
ويكنسل مع بعض ويتبقى F.
Yes, I can cancel them out. So now I have the following. If you cancel out L inverse with L, so you have f of t is given to be inverse of f capital of s. So the inverse function, the inverse Laplace transform, sorry, is similar to the relation between antiderivative function and the differentiation, integration, and something like that. Okay? Let me give you an example. Do you remember in the previous lecture, and take care please, those 2 coming weeks here, which we are going to study in this week and the coming one, need Laplace transform. So please, your cheat sheet for Laplace transform must be prepared from now. Here, I remember from the previous lecture that I have this rule. Laplace of t is given 1 over s squared. If I try to take the inverse for both sides, so here Laplace inverse and here Laplace inverse, okay? I'm going to cancel out this L with L minus 1. So I have Laplace inverse of 1 over s squared is given to be t. So the rules for Laplace inverse is very, very similar to the rules for Laplace. In the coming slides, I'm going to add also here the rules of Laplace. So those rules we studied in the previous lecture. Laplace of number 1 is 1 over s. Laplace of t to the power any number will be the factorial of that number divided by s to the power plus 1, the exponential, cosine, cosine, sine, cosine. Those rules you have to memorize or write them on your cheat sheet. Here the inverse, notice now this slide, the new slide now, the rules of inverse Laplace transform. The rules of inverse Laplace transform. So inverse of 1 over s, it is 1. Inverse of 1 over s minus 1, it's the exponential. Please take a photo of this slide. Take a photo of the inverse Laplace transform table. I need this one now to solve many problems. I will ask you to answer me. Please take a photo and you have to check the answers from this table. Now, before I start solving some problems, let me introduce here the most important probability of the answer of Laplace transform. How to explain the theorem? Now, let us consider that we have the function f of t. So I will give you function f of t. Okay? And I asked you to find its Laplace transform. It will be f capital of s. So here Laplace of f of t, it will give you a new function. We call it f capital of s. Now, this f capital of s must tends to 0 when s tends to infinity. So if the function f capital of s, it is really Laplace transform of a specific function piecewise and continuous of exponential order, then the limit of your answer must be 0. Let us check. Let me consider that my function f of t, it is t squared. Okay. And I'm going to find Laplace transform of my function t squared. I remember the rule, Laplace of t to the power n, which you have to write in your cheat sheet, is given to be factorial n divided by s to the power n plus 1. This rule. I'm going to use this rule with my n to be 2. So I have factorial of 2 divided s to the power 2 plus 1, which is 2 divided s power 3. This is my f capital of s. Now I'm going to check if this function satisfies my theorem or no. So I need the limit of f of s when s tends to infinity, which is the limit of 2 over s to the power 3 when my s tends to infinity. So 2 over s to the power 3 when s tends to infinity is 2 over infinity is 0. So nice. Always the limit of fs be 0 when s tends to infinity. But if I give you a function f capital of s, and I will ask you to check if this function can be considered as a Laplace transform of a specific function or no, you have to find its limit. If the limit is 0, yes, that function is the Laplace transform of this specific piecewise continuous of exponential order function. But if this answer isn't 0 when s tends to infinity, so this function, this one, isn't a Laplace transform for any piecewise continuous of exponential order function. Let us study those two examples. Let us consider my f capital of s is 1. You need to check the limit of your function f of s when your s tends to infinity. Equal, I have only constant, so it's 1. Not 0, so this function can't be considered as a Laplace transform of any piecewise continuous function of exponential order. Let me check this function. I need to find its limit. So limit s over s plus 1 when my s tends to infinity. So what do you think about this limit when s tends to infinity? Can you help?
1.
1. And
هو
this
يا دكتور
Yes, and this isn't 0. So this function can't be considered as a Laplace transform of a piecewise continuous function of exponential order. Did you get the idea of the probability of the Laplace transform for any function? Its limit when s tends to 0 to infinity must be 0.
Doctor, why is the limit equal to 1?
Repeat.
Why is the limit equal to 1?
Why? Your question, if the limit is 1, the answer is 1. So what we should say? This is your question?
Why is it 1?
Here, why the limit is 1. Yes, your question, why the limit here is 1. Actually, if I have a fraction up and down, and you need to plug in infinity, so you have up infinity and down infinity. So it's undetermined limit. So I'm going to apply L'Hopital. Up and down, the differentiation of up and down, it will be 1 divided 1. So the answer 1. This is the first method. Second method to check this limit or to find this limit, I have a rule. If I have polynomial here and polynomial down, and I need to find the limit for infinity, take the highest power up and highest power down. So it is s divided s. So s divided s, it is 1. This is your question?
Yes.
Yeah.
Thank you.
Welcome.
Doctor,
Yes.
what about the condition of exponential order? We do not use this condition again one day.
No, now look, usually, if I give you function f of t, okay, and I ask you now, check if you can find Laplace transform of this function or no. Okay? So my question, is there any Laplace transform for this function or no? Now, you have to check if your function is piecewise, this one, piecewise and f exponential order. If my function, if it is piecewise and exponential order, yes, there is Laplace transform for this function. There is Laplace transform for this function. Okay? Now, if one of those conditions isn't satisfied, you can't say anything. This for f small. Now, the new thing we studied now, if you have f capital of s, I need you to check if this function is the Laplace transform of any specific function of t, such that this of t of exponential order and piecewise continuous function. How to check if this one is really Laplace transform of this? You have to find the limit when s tends to infinity. If your answer is 0, yes, this function is Laplace transform for a specific of t, f of t. But if the limit isn't 0, so no, this function isn't Laplace transform for any piecewise continuous function of exponential order. Did you get the idea, Mahmoud?
Yes, يعني احنا we're checking for the answer of the plus, right?
Here, you asking me about this?
Yes, يعني احنا
Yeah, usually, Mahmoud, you have two different problems. I will give you this, and you have to check those two conditions. Or I will give you f capital, and you have to check this limit.
okay.
So those two different problems.
Okay, thank you.
Okay. Other students? Now, let me remind you the linearity probability. I think now all of you are familiar with the linearity probability. If you need to differentiate the summation between two functions or integrate between the summation of two functions or find Laplace transform of a summation between two functions, you will find Laplace of the first and the second, and also for the inverse Laplace transform. If you need to find the inverse of the summation between two functions, you will find the inverse of the first and inverse of the second. Let us apply this rule to solve those problems. I'm going to solve two of them, the first and the third one, and you need to do this and send it to me on WhatsApp as a private message. Okay, let me do the first one. I need to find the inverse Laplace for the following functions here. I'm going to use this pen now, and together we need to find the inverse Laplace of this function. Now for me, first step is to check my table. Please go to the photo which you take for the Laplace inverse, and please tell me, could you find this function in your table? S plus 1 divided S squared plus 4. Can you find it?
Not exactly, Doctor.
Not exactly. So starting from now, from this moment, if you can't find your function in your Laplace inverse, please try to simplify your function, to change its form to be similar to what you have in your table. Any step?
Can separate the fraction.
Yes,
into
let
two
me
fractions.
separate my fraction into two fractions. So Laplace inverse of S over S squared plus 4 plus 1 over S squared plus 4. Great. Now I have inverse of summation. That means it is inverse of the first, which is S over S squared plus 4, and inverse of the second, which is 1 over S squared plus 4. Am I right here? Now please check your table. Can we find this in our table? S over S squared plus 4, yes.
Cosine.
Cosine, yes. Cosine what, but? It is cosine, you are right. Cosine
Sine
what?
kt, the k is 2.
The k is 2, great. So 2t, because the 4, it is 2 squared. And the rule said k squared. So cancel the squared, so you have only 2, great. Do you want me to go back to the table of rules? Anyone of you need me to go back to the table of the rules? No one. Great. What about of this one? What about of this one?
Sine the
Sine.
same angle, يا دكتور.
Repeat, Omar. Let me listen to Omar. Repeat, Omar.
Sine.
Sine. Are you sure, or do you need to add or multiply by something? What do you think? Actually, you are right. It's very close to the sine rule, but I think I missed something here.
There's a
Multiply by
k.
2.
There's a k.
Yes, the k is 2, so you need to multiply by 2 here and
Yes.
divide by 2 out. So here times 1 over 2. So here plus the half, don't care about the constant, and here sine 2t. We finished. Let us go to second problem. Yeah. Do we have this one in our table? No. So you need to change the form of your function.
We can expand the brackets and try to
Yes,
simplify.
expand the bracket up. Yes. So here I have squared of the first, negative 2 first times second, plus the squared of second number divided S cubed. Now, what should I do now? What should I do now?
Separate them, maybe.
Separate the
Yes,
fractions.
separate, yes, S squared divided S to the power 3 minus 2S divided S to the power 3 plus 1 over S to the power 3. Now the linearity probability, I'm going to choose each one, but here I can cancel out squared with cubed, and here the S with the power 3. So I have Laplace inverse, so Laplace inverse of the first fraction, which is 1 over S. Minus 2 constant, take it out from Laplace inverse. Here you have only 1 over S squared. And the last one, it is Laplace inverse of 1 over S to the power 3. Now for me, I know the rule for this. It is what? 1 over S, inverse of 1 over S, it is what?
1 يا دكتور.
1. What do you think about second one? Second, this negative 2, Laplace of 1 over S squared.
دي تبقى 2 بقى ولا تبقى
2? I'm not sure.
لا أنا
The
بحسب.
2 here. You are speaking about this 2 or this 2?
I'm guessing يعني إن 1 over S square ممكن تبقى 2.
2 impossible. You can't guess because you have table, and from your table you can find the answer. 1 over S squared. And if you
t
need
to the power of 1.
t to the power of 1. Great, Muhammad. So let me write here the rule, and you can decide that. So I have the rule here, Laplace inverse of n factorial divided s to the power n plus 1 is given to be t to the power n. Now for my problem, I have 1 factorial up and down n. So your n plus 1, let me write here for this in red, the n plus 1 is what? For this, it is 2. So your n is what? N is 1. So your answer t to the power 1. So t to the power 1. I'm going to use another color, or t to the power nothing as you need. Another color to check the second one. Now for this, my n plus 1, it is 3. Am I right? Here, this n plus 1, and this is your n plus 1. So your n is what? Your n is 2. So you need up 2 factorial. Where is 2 n factorial? Here 2 factorial. So I'm going to write here 2 factorial, and I'm going to divide by 2 here. Is it clear now? For the red one here. So plus the half, and the answer, it will be 2 to the power, t to the power, my n is 2, t squared. Is it clear? Any question? So let us solve more problems. I think it's very important to solve a lot of problems because those are very important. I have 3 here also, A, B, C. You need to do C and send it to me by WhatsApp as a private message. And I'm going to do A and C. You have to do B. Okay? Now, let us try to do number A together. Here, this one. Let me use the yellow and try to find the inverse of this function. Could you please check your table? Do you have similar to this formula? Do you have similar to this formula?
No, yellow.
No. So you have to change the form of your function. Please choose suitable steps to change the form to make your function similar to those in your table. Any idea?
Expand the brackets.
Expand. So by expanding the bracket in the exam, you will lose 10 minutes and 10 marks. Yeah.
Multiply them.
Expand is similar to multiply.
لا يعني دون.
Yes, Amar? What do you think?
We can separate them into 3 fractions.
Yes. What do we call this technique? What do we call this technique?
Partial fractions?
Partial fractions. Do you remember the integration? It's very similar to the integration. So I'm going to do the partial fraction. Here equal. First fraction with numerator A and denominator first bracket. Second fraction, it is B with the second bracket. Third numerator is the new constant C divided S minus 3. Partial fraction. Do you remember how to find those constants A, B, C? Can anyone of you remember? What? Do you remember?
We can cover S minus 1 and substitute 1.
Yes. So do you want me to multiply my equation by the denominator of A and give X? It is S, by the way. Why it is X? It is S. I'm so sorry. So I understand your idea, David. Anyone of you can suggest a suitable method also to find those ABC? So you are 3. I think all of you studied partial fraction in calculus 2. I'm going to do maybe 2 or 3 problems in details. Then I'm going to let you do that. Now for me, what I'm going to do, I'm going to make all those denominator have common denominator, so the same denominator, then omit this common denominator. So I'm going to multiply here by S minus 2, S minus 3. I'm going to multiply here by S minus 1, S minus 3. I'm going to multiply here by S minus 1, S minus 2. And this will be here and here, here and here, here and here. At that time, I have the same denominator. I'm going to cancel it out. So I have the following. S plus 1, the left-hand side, equal. My A is multiplied by S minus 2, S minus 3. My B is multiplied by S minus 1, S minus 3, S minus 1 and S minus 3. And notice that your C is multiplied by S minus 1, S minus 2. Now you need to find the values of those constants. Let me call this equation star. From equation star, sorry, just 1 minute. Let me use another color. Green. So here, to find the value of the constant A, I'm going to give S equal specific value, which will eliminate or will make B and C with coefficient 0. So can anyone guess? 1. And by the way, as David said, Professor, when you need to find A, you need to let its denominator 0. So the S is 1. Now, if the S is 1 in my equation star, help me please. 1 plus 1, it's 2, equal. A, bracket. 1 minus 2, it's negative 1, times 1 minus 3, it's negative 2, plus B. Here, 1 minus 1 times anything, it's 0, plus C. 1 minus 1, it's 0. So I cancel out this with this. So that will give me 2 equal. Negative times negative, so it's negative 2A. So my A is 1. I found the first constant. To find the second constant, B. Can anyone guess the value of C, which I need to use now? The value for S?
2.
2, to make the denominator 0 in equation star. Now, 2 plus 1, it is 3 equal. A. 2 minus 2, it's 0. Notice now, when you need to find B, that means the coefficients of A and C must be 0. Plus B, help me please, 2 minus 1, it's 1. 2 minus 3 is negative 1. Plus C times S minus 2, this one, S minus 2, it's 0. So that will give me 3. I'm not sure if I did something wrong here. No, all things are right. So the B is 3 equal negative B. So my B is negative 3. Great, I found the second constant. Now to find C, I'm going to give S the value 3, because that will make the constant, the coefficients of other constant zeros. In equation star, I can write the following. 3 plus 1, it's 4, equal. A times 0 plus B times 0. I know those zeros. Plus, now my M is C. 3 minus 1, it's 2. 3 minus 2, it's 1. So I have 2C equal 4. That will give me my C to be only 2. Those are my constants. So now, if you need to find, let me use the yellow. If you need to find the inverse of the function f of s, instead of using all this complicated fraction, I'm going to use those 3 simple fractions. The first one, A. What is my A is 1. So I need to find inverse of the first one, which is 1 over s minus 1. Second one, which is B. Don't care about the number. So take negative B, negative 3 out the Laplace inverse, and you have 1 over s minus 2. And also take the 2 outside of the inverse because it's a constant, and you have to find 1s minus 3. Now, which rule should I use to find the inverse of this? Check your table, please. All of you, please.
The rule of 1 over s minus a.
Great. Let me write here the rule. So, some suggest, Professor, I can use the following rule. Laplace inverse of 1 over s minus a is given to be what?
E to the power of at.
80. Yes, I can use this one. So here it is e to the 1t minus 3 e to the 2t plus 2 e to the 3t. Using this rule. What do you think? Is it clear?
Yes, يا دكتور.
Let me solve another problem. So here, new slide. This one. Yeah. Do we have this formula in our inverse Laplace table or no?
No يا دكتور.
So we have to simplify it. Who can help to simplify this fraction now?
Can we split the denominator?
Could you please explain more, Omar? So what should I write now? I'm going to use the blue now. Just 1 minute, Islam. I need Omar to speak. By the way, if you didn't do some mistakes, all of you, if you didn't do some mistakes, you can't do the correct steps in the exam. You have to learn the correct steps and to know the wrong steps. Omar, could you please speak?
Yes, يا
What
دكتور.
should I do now? Yes, I need your idea. Your idea will help not only you, all the students. So what do you want me to do? Split the denominator?
يعني اللي هي ال S to the power of 4.
Continue? I can't hear you, Omar.
S to the power of 2 minus 1.
Yeah, your denominator. You are speaking about the denominator.
Yes.
Yeah, actually, it isn't split. You said split, and for me, split word that means divide it into 2 parts. So I have 1 fraction, split it, that means I have 2 fractions. I think you need to say factorize and use this rule. A squared minus B squared equal A minus B times A plus B. Am I right, Omar? Do you want me to use this rule?
Yes.
Yeah, we call this one difference between 2 squared or factorizing the bracket. Okay, not split. For me, I thought you need me to split this fraction into 2 fractions as we did in the previous example, but now we can't because I have only 1 numerator, only 1 term in the numerator. Okay. Yes, great, Omar. Great, Omar. Now, so Omar suggests to factorize the denominator by writing the identity. It is S squared minus 1 and S squared plus 1. Am I right, Omar?
Yes,
so let me write here the rule for the students. For those who forget, A squared minus B squared, it is A minus B times A plus B. Yes, Omar. Now, by the way, can I factorize the denominator more? Can I do more factorizing steps?
Yes.
Yes, S squared minus 1. So it is S squared divided. It will be also S minus 1.
S plus 1.
Yes. Can I factorize the S squared plus 1? No, I can't.
No.
Yes, great, Omar. Yeah, but unfortunately, till now, I don't have forms similar to my table. So what should I do?
We can apply بقى هنا
partial fraction. Great. So I'm going to write here. I'm going to write, where should I write? I can write here. So I can write here. It is A over S minus 1. I'm sorry, plus B over S plus 1 plus C. What do you think about the numerator of this one? The numerator of this one, it will be what?
S plus D.
C S plus D.
Yeah, you are right. So S plus D. So if your denominator of second order, you need your numerator to be of first order. Also, you have many methods to find your constants. For me, maybe I found this is easiest one for the students, to let all the fractions have the common denominator, then omit this common denominator. So I'm going to multiply here this. I'm going to multiply it by S plus 1, S squared plus 1. I'm going to multiply this by S minus 1, S squared plus 1. and I'm going to multiply this by s minus 1, s plus 1. Don't forget up and down, up and down, up and down. So you have, yes.
What other methods, doctor, do you mean here?
Yes, other methods. Yes, one of them is to equate between the coefficients, okay, of s, and the second one, for me, I can from this equation, multiply here by the denominator of s minus 1. Then I'm going to multiply by the denominator of s plus 1 without making the fractions have the same denominator. By the way, all those methods or techniques are from one origin, so from the same source, okay? But some professors use this step before this, and other use the second step at the beginning, okay? My aim is to determine the value of those constants. In the exam, if you used your calculator to find A, B, C, D, you will get a full mark of those constants. And also, if you cheat them from your colleague, you will get full mark for those constants, but it must be correct, okay? So now I'm going to write my equation without the denominator. So I have s squared equal, the a is multiplied by s plus 1, s squared plus 1. The b is multiplied by s minus 1, s squared plus 1. And the cs plus d is multiplied by s minus 1, s plus 1. Now let us try to find the constants A, B, C. I'm going to start finding the constant A. Let me call this equation star. So to find A, I'm going to choose my S to be what? Can anyone guess? My S must be what? As I said, you need to determine the value of this S is such that the denominator of A is 0. So it will be what?
So it will be 1.
1. And at that time, you will cancel out this and this. So S equal 1. That will give me an equation star the following. 1 squared, it is 1, equal A times bracket 1 plus 1, it's 2. 1 squared, 1 plus 1, it's 2. Plus here, S minus 1, it's 0. And also for the CS plus D, it must be multiplied by 0. Cancel out this and cancel out this. So A equal 4A. That will give me my A is 1 over 4. To find B, I'm going to choose my S to be what? What value? What do you think?
-1.
-1. In equation star I have now. -1 squared, it is 1 equal A times 0 plus B -1 and -1 -2. -1 squared, it is 1 plus 1, it's 2 plus all the bracket multiplied by 0. So I have 1 equal -4B. My B is -1 over 4. Yeah. Which constant from C and D do you want me to find before? Let me find D. So now you have only two unknowns, the C and D. If you choose your S to be 0, so you have only one unknown, D. Am I right? If you choose your S to be 0, so you have only one unknown, it is D. Take care. No S can be repeated. No S can be repeated here. 1, -1, 0. You can't repeat any one of them. That will give me if my S is 0. A0 equal A times 1 times 1 plus B times -1 times 1 plus 0 plus d bracket negative 1 plus times 1 here, because 0 and here 0. That will give me. I know, so here I have negative d. Let me write in details. 0 equal. Here you have a. What is your a? Is 1 over 4. Minus b. Minus b. And your b is minus, so it is a plus. 1 over 4 minus d. Move d, so d equal 1/4 plus 1/4. It will be 1/4 plus 1/4. 1/2. This is my d. I found the d. Now only I need to find c. Who can help? Who can help? Who can help?
Any value, doctor. يعني
Any
two.
value, yes, any value for s. But you can't repeat any one of those. So let me choose the s equal to great. This is one method to find c. Other students will multiply those brackets and equate between the coefficients. You are free. Now for me, I'm going to choose my s to be 2. So 4 equal, in star, 2 squared 4 equal a times 3 times 5. I'm plugging s equal to plus b times 1 times 5, which is squared plus 2, plus 2c instead of s, plus the d times 2 minus 1, which is 1, times 3. Yes, let me plug in the values of the constants. So 4 equal. Now the a is 1 over 4 and 3 times 5, 15. So 15 over 4. The b is negative 1 over 4. So it's negative 5 over 4. Plus, I'm going to multiply this 3 inside. So 6c plus 3d. 3d, so it is a 3 over half. 3 over 2. 3 over 2. That will give me, let us check. Now 15 divided 4 minus 5 divided 4, it's only, am I right here? I think I'm right. Here it is 2 plus 1, and here it's, yes. So here 2 times 3 over 2. Those are 10 over 4, which is 5 over 2. 5 over 2 plus 3 over 2, it is 8 over 2. 8 over
4 يعني يا دكتور.
Yes, it's 4. Move it to the left-hand side, it will be 0. 6c equals 0, so my c is 0. I found the c's. In the exam, to find this a maybe half or 1 mark, half or 1 mark, half or 1 mark, half of 1 or 1 mark. Okay? Now, after finding all those constants, I'm going to black slide now to write, instead of my fraction, those 3 fractions. I'm not sure if I have a black slide here now. Yes, I have one. So if I need to find the inverse of my function, which is s squared over s to the power 4 minus 1, it's better to find the inverse of the following fractions. Where is the fractions now? It is a over s minus 1, and a is 1 over 4. Laplace inverse of 1 over 4 of s minus 1 plus b over s plus 1, so negative 4, negative 1 over 4, Laplace inverse of negative 1 over 4 divided s plus 1, plus Laplace inverse. My c was 0. My c is 0 here, as you notice, so no need to write cs. The d is half over s squared plus 1. Okay, now I'm going to take the numbers out of the Laplace inverse. So 1 over 4, Laplace inverse of 1 over s minus 1. This one, it's very easy. Check in your table, please. Negative 1 over 4, Laplace inverse of 1 over s plus 1. Check your Laplace inverse table, please. Here also plus half, Laplace inverse of 1 over s squared plus 1. Yes, help me please. The first one, it is what? It is what?
e to the power of t.
E to the power of t. You are right. Now, starting from now, I'm going to choose one of you. Yes, continue, please. This one, I understand this, but this one, it is a plus here. What should I write if it is a plus? It's similar to the rule of exponential, but the rule of exponential must be minus. So what do you
So
think?
it's negative t. E to
Yes,
the
you
power
are right. You are right. So negative 1/4 e to the negative 1t. What about of the last one, please? This one. Do you have it in your inverse table?
sine.
Yes, you are right. Sine t. Please, all of you must participate. You will understand more. And be sure, I believe that any students must understand the materials of the lecture during this lecture. You have to start to understand at least 80% of the materials during the class. Okay? Any question? Who finished here? Great, we finished. Any question here? No questions. Let me go now. I need you to write your names, please. Write your names, please. And here, this slide, I'm going to introduce the Laplace transform of derivative of my function. So I think all of you know that you need to find the Laplace transform of the function f of t. You can write it is f capital of s. What about if I need to find Laplace of a derivative of my function, not my function, or second derivative of my function, or nth derivative of my function? Actually, I have those rules. The Laplace transform of the first derivative is given by this formula. S times f capital, which is Laplace of my function without any derivative, minus f of 0. Second derivative, Laplace of second derivative, it is squared, notice, 2 primes squared of f capital of s minus s f small of 0 minus f prime of 0. Now, actually, I'm going to prove one of them because some students need me the theoretical concepts of the rules. So I'm going to prove one of them. But before that, let me read here the general formula. If you have nth derivative, so your answer, it will be f capital of s, which is the Laplace of your function f without any prime, times s to the power n, the same n. Then you will subtract 1 for s, and you go back to your function at 0. Subtract 1. Now first derivative, and so on. Notice here, the number of the prime here, it's 1. Plus n minus 2, those are n minus 1. And here also, here 0 prime, plus n minus 1, it's n minus 1. And also here n minus 1. Don't care about this. But what I need you to understand now, and please help me to determine f3 primes. So I'm going to write with you here f3 primes. I need you to find Laplace of f3 primes of t. Notice, if you have 1 prime, so you need to multiply by s to the power 1. If you have double prime, so you have double 2 squared, sorry. So here you have s to the power 3 times f of s. The general rule said minus. Subtract 1 from the s power of the s, so it is s squared, times f of 0, minus. Subtract 1 and differentiate f of 0, so s f prime of 0, minus. Subtract 1 from the power of s, which is s to the power 0, which is 1, times add 1 prime here, so f2 primes of 0. So those 3 rules are very important. I need them because they will help me to solve initial value problems. Now, let us prove the first rule that Laplace. So I'm going to prove with you now. Let me use another color. It's better to use the yellow, I think. Let me prove that Laplace of f prime of the function t of variable is given to be s f capital of s minus f of 0. Don't forget, f capital of s, it is the Laplace transform. Don't forget, f capital of s, it is the Laplace of f small of t. I need to prove this. So here the proof. Let me take the Laplace of f prime of t. Can anyone help now? How to find the Laplace of f prime of t? I don't know f. I don't know f prime. So what should I do? Who is speaking? I can't hear you.
Use the rule يا دكتور.
Use the rule? Great. Which rule? Which
in
one?
the previous slide.
No, Omar, I need you to prove it. So in the exam, maybe I will ask you to prove the rule, but only the rules which I proved in my lecture. So now I'm going to prove the rule.
Okay.
Yeah. For me, do you have a rule in your table for f prime? No. But for me, I remember the definition of Laplace transform is given to be the integral from 0 to infinity exponential function of negative st times my function. Am I right? This is the definition of Laplace transform. Now, how to find the value of this integral? How to integrate this product between two functions? Who can suggest an idea to integrate a product between two functions? What do you think? If you have a product and you need to integrate, which rule do you need to apply?
By parts.
By parts, yes. Which one do you want me to choose to be dv? And which one do you want me to use to be du? Which one must be dv? Which one? The derivative f prime. So this is my dv. So the v, it is f of t. And this one, it is my u. So my du, it is negative s e to the negative st. And I remember the rule, it is uv minus integral of video. Don't forget the limits from 0 to infinity, from 0 to infinity. Let me go back to the yellow and plug in the functions now. So equal my u, it is e to the negative st, times my v, it is f of t from 0 to infinity, minus integral my v, it is f of t, times du, which is negative s e to the negative st, all dt. And by the way, here you have dt. And from 0 to infinity, let us plug in the infinity first, then 0. And I'm going to discuss with you how to find this integral. Now, infinity, e to the negative s infinity, e to the negative s infinity, it will be what? The negative s infinity. I need help. E to the negative s infinity.
0.
What about if your s is negative 1? So you need the condition s greater than 0. Okay? If s greater than 0, so e to the negative infinity, it's 0 minus, now you need to plug in the 0. So e to the negative 0, which is 1 times f of 1. So here f of 1 minus, here negative is a constant, take it out, so plus s integral. Here inside the integral, I have the exponential times f of t dt. Yeah. I'm sorry here. Why I wrote here 1? From where this one? What about of this one? It must be 0 because I'm trying to plug in the values of 0. Please focus with me. Are you sleepy or hungry or what? Focus with me, please. So now, yeah. What about of this integral? What about of this integral? You have to know it. It's a famous integral. What do you think about this?
هو مش ده
Laplace of
Laplace
t.
transform؟
Yes, yes,
Yeah,
yes. This is
Laplace
the
of f
Laplace
of t.
transform, Laplace of the function f of t. You are right. You are right. So equal s times Laplace of f t. It is f capital of s minus f of 0. This is your left-hand side. Right-hand side, I'm sorry. So I proved the rule. I need this rule to solve the following initial value problems. Are you ready now to solve initial value problems? Here are the examples. Actually, be sure also in your exam at least 2 problems similar to what we are going to do now. At least 2, or I think no, not at least 2. I'm sure there are 3 problems similar to what I'm going to do now. So focus, please. The question is asking me to solve this initial value problem. Do you remember how to solve an initial value problem similar to this? Actually, I need you to do it using integration by part. Sorry, using Laplace. But for you, how to do this differential equation? How to solve this differential equation? How to solve
Separation of variables.
Yes, you can do that. I'm not sure, but if you will success to do that. But
يبقى
maybe
homogeneous ده.
homogeneous. Also, maybe I'm not
Or
sure.
it can be linear.
Yeah, I'm sure that this equation, it is first order linear. To solve it, I need to find mu and apply the second step. Okay. So sometimes you can solve the equation using more than one technique. In the exam, I will give you one equation which can't be solved using any one of the previous technique, and at that time you must use Laplace transform. Okay, but this one, if you have this one in your exam, you can use the first order, or maybe if you can separate, I'm not sure about that, or homogeneous, but I'm sure you can solve it using the first order linear technique. Now I'm going to solve it using Laplace transform. Focus, please. Here the solution. First step, please try to memorize those steps. I'm going to solve this differential equation using Laplace transform. So let us take Laplace for all terms in my equation. So Laplace of y prime plus Laplace of 5y equal Laplace of t. That will give me, do you remember the rule of Laplace y prime? Do you want me to go back to the rule? Where is the rules? Laplace of y prime. Where is the rule? Here, the rule here. Notice Laplace of y prime. It is so now instead of f prime, I have y prime. So y prime. So it's f minus f. So s y capital. Let me write y capital. So here, I'm so sorry, we didn't finish. So here it is as the rule s y capital of s minus y small of 0. I applied the rule plus. For me, I know that number 5 is a constant. Take it out. Laplace of y small equal. I remember Laplace of t from my Laplace table is given to be Laplace table. Laplace of t, I forget. I need some help. I don't have my table. Check your table. Laplace of t. Anyone can help?
1 over t squared.
1 over t squared.
S
So
squared, I'm sorry.
S. You are right. So let me erase this, and it is S squared. You are right. So please, you have to practice now. The final is very close. Okay? And the final is comprehensive. So it isn't easy to study before the exam because you have only Friday and Saturday those to study. Now let us continue. Y of 0, I have it here. It's 2. So I have S, Y of S, yes, minus 2 plus 5. What about of Ly small? Laplace of Y small. It is what? Laplace of Y small. Do you remember? It is Y capital. We agreed that small will be capital if I apply the Laplace equal 1 over S squared. Now, I'm going to take this Y from here and here common factor, and I'm going to move 2 here. That will give me, if I take Y common factor, so I have S plus 5. And here I have 1 over S squared, 1 over S squared plus 2. Now, second step is to eliminate Y capital S. So Y capital S equal, divide by those, divide by the coefficients. So it is 1 over S squared all over S plus 5 plus 2 over S plus 5. So that will give me the function Y with the variable S is equal 1 over S squared S plus 5 plus 2 over S plus 5. This is my Y capital of S. Second step, no, it is the third step, is to take inverse Laplace for this equation. So Laplace inverse of Y capital of S equal Laplace inverse of 1 over S squared S plus 5 plus Laplace inverse of 2 over S plus 5. Okay? So you have to write those steps, not like what I wrote now. You have to write in your cheat sheet to solve any differential equation using Laplace transform. First step, apply Laplace for all terms. Second step, get Y capital of S. Third step, find inverse of all terms. Now let us continue. Tiny question. What is the inverse Laplace of Y capital of S?
Y small of
Y small of t. You are right. So this it is Y small of t. And by the way, Y small of t is my solution. I need to find Y. Nice. Equal. How to find the inverse of this? No, it is difficult. This one, it is very difficult to be found. I'm going to check how to do that. Leave space here, plus. How to find the inverse of this? The 2 is constant, take it out. I remember the rule. Let me use another color to write the rule. I remember Laplace inverse of 1 over S minus A is given to be e to the a t. Can I apply this rule for this fraction? What do you think?
Yes,
e to the negative 5t.
E to the negative 5t, great. So 2e to the negative 5t. What about of this, Professor? What about of this? How to do this one now? Actually, I need space, so I'm going to black slide. And I'm going, but I need, before I go to the new slide, I need one to help. How to find this? So it is my fraction 1 over S squared times S plus 5. How to find the inverse Laplace for this function? Do you have partial fraction also? Also partial fraction here. So I'm going to write. I hope you can remember the partial fraction if you have S squared. So I'm going to write A over S plus B over S squared plus C over S plus 5. Do you remember those rules to do partial fraction? Now I'm going to use the red maybe to have the same denominator, then cancel out the denominator, the common denominator. So here I need S plus 5, up and down. Here I need only S plus 5, up and down. Here I need only S squared, up and down. So omit the common denominator, I have 1 equal A times S times S plus 5. This is an S plus B times S plus 5 plus C times S squared. Am I right here? What do you think? Yeah. Now, please, I need one to help. I'm not going to write by my hand, by my own. I need one to help. What should I do now? Which constant do you want me to find first?
It's -5. We can find the C.
So you want me to find C first? Yes. C. How to find C? The value of S must be what?
5.
5. Great, Islam. That will give me an equation star. So you are free. You can start finding C, B, A. You are free. S equal 5. So I have here 1 equal A times 5. The S is 5.
-5.
I think it's -5. You are right. It's -5, not 5. So you need to make the denominator is 0. So -5. So here -5 times 0 plus B times 0 plus C -5 squared, it is 25. So now this is 0, cancel out. So my C is 1 over 25. Yeah. Second constant. Which one do you want me to find? Which one?
Find B by
B.
putting S equal 0.
So he asked me to find B by choosing my S to be 0. In equation star, let me check. 1 equal. My S is 0, so A times 0, so it's A0. Plus B, here is 0, I'm sorry. B times 5 plus C0. So my B is 1 over 5. How to find A? How to find A?
Yes, any value.
Give S any value. So S equal 1 maybe. That will give me an equation star. 1 equal A times 1 times 6 plus B times 6 plus C times 1. That will give me 1 equal 6A plus 6B. So it is 6 over 5 plus 6 here it is I'm sorry, here it must be C. Am I right? It must be C. So it must be 1 over 25. How to add those together? I'm going to multiply here by 5. So 31, move it here. 31, it will be negative 25, -6, divide by 6. So my A, it is -1 over 25. To find each one of those constants, maybe half mark or maximum 1 mark. I found the constants. So now I have this fraction. It is, instead of A, I have -1 over 25 over S. Instead of B, I have the value 1 over 5 over S squared. And instead of C, you have 1 over 25 over S plus 5. Let me go back to the white one and to find inverse Laplace. So inverse Laplace of my fraction, which is S squared S plus 5, is given to be inverse of the first one, and take the number outside, 25, Laplace inverse of 1 over s. And also here I have 1 over 5 as a constant, so take it out. So you have inverse Laplace of 1 over s squared plus 1 over 25 as a constant, Laplace inverse of 1 over s plus 5. Yeah. Your table, please. Laplace inverse of 1 over s. It is what? 1 over s, please.
1 يا دكتور 1.
1 plus 1 over 5. Laplace inverse of 1 over s squared.
T to the power of 1.
T to the power 1, great. Plus 1 over 25. Laplace inverse of this s plus 5.
The sign
No, the sign needs square. Your table, please.
يبقى e to the power of negative.
E to the power negative 5t. Please try always to check the table, and for those who participate now will find Laplace transform easy, but those who are sleeping now, they will find it's very difficult. And the final exam, it is about 60% of the new materials. 60% out of 100 will be of those new materials. After finding this, go back to your solution. So here in yellow, I'm going to add those, or let me write them in white. So negative 1 over 25, negative 1 over 25, plus 1 over 5t, plus 1 over 5t, plus 1 over 25, plus 1 over 25 e to the negative 5t. This is the solution of this initial value problem here. Here, initial value problem, and here the solution. You can solve it using the first order linear technique and check if you get the same solution or no. Do you have any question? Don't forget the steps. First step, Laplace transform all terms. Second step, find y capital. Third step, take inverse to get y small. Okay? Actually, I don't think we have time. What do you think? How many minutes do we have now?
It's 12:45 يا دكتور.
Yeah. Actually, 44 here. And my laptop is 44. So we have 1 minute, Omar. Okay. Yeah, I'm not going to solve because it's need maybe 15 minutes to do this differential equation. You can do it by your own and send it to me on WhatsApp. And by the way, we can meet at 1 o'clock to do similar to this equation, which is in your cheat sheet, worksheet. If you need, you can join at 1 o'clock. We have 3 problems, one of them similar to this. So I'm going to do the one which is similar to this at 1 o'clock, okay? Actually, I didn't start grading the exam. Maybe I will start tomorrow, I'm not sure. Now, do you have any question? Any questions? So we can meet at 1 o'clock if you have any difficulties to do the worksheet. And have a nice day.
Thank you.
Welcome all of you.
Thank you, doctor.
Welcome and bye-bye.
Thank you يا دكتور.
Bye-bye. Welcome, Omar. Bye-bye all of you.